Hello everyone. This is my presentation for paper fully automatic 3D feature expression recognition using local depth features. My presentation includes 4 parts. First, introduction. This paper proposed a fully automatic method for 3D feature expression recognition. The proposed method could be fully automatic because we do real-time fiducial points detection. The proposed method can achieve a good performance because we performed feature selection on local depth feature. Before I go into the details of the proposed method, I'd like to show the 3D faces include the BO3D database. In each column, it's the same expression. You can notice the expression variations, and also can see the noise on the original 3D faces. This figure shows how my method worked. First, we do date pre-processing, and then we do feature extraction, followed by feature selection, and at last we do classification. In pre-processing, we generate depth image from the 3D faces, and we calculate its XY gradient image. Based on these images, we train a height detector to detect 5 fiducial points. These 5 points are used to generate a T area to do the face alignment by ICP, and also we generate 25 heuristic points to cover the whole face. And at last, all the points are located on the original 3D faces. Once a point has been located on the face, we put a sphere centered at these heuristic points to crop the point cloud out, and a cubic patch is fitted to the cropped points. And then we sampled the cubic patch with a uniform 64 by 64 grid in XY plane. So the Z directions, the depth information, can be recorded in a 64 by 64 matrix. Clearly, for a small local patch, 64 by 64 is quite a high dimension, so we performed 2D PCA for dimension reduction at first, and then we do the feature selection. The idea of feature selection is that the M best features are not necessarily to be the best M features for classification, because they may have redundancy. So from the MR and MR criterion, we can see that we try to select the best features by minimizing the redundancy and maximizing the relevance at the same time. And at last, the selected best features are given to SVM for classification. Then in my experiment, I followed the commonly used 54vs6 setup to guarantee a person-independent recognition. I repeat 10-fold cross-validation 20 times. This figure shows the recognition rates. You can notice the variations of the recognition rates. So in order to ensure unbiased result, the reported result is the average rates of all the 20 times. In this table, we compared our method with other existing methods. From here, we can see this paper, the proposed method outperformed other automatic methods by almost 5%. And also, my method is also comparable with manual methods. This method relied on manually labeled landmarks. At last, I'd like to conclude my method in 2 points. First is the proposed method outperformed existing fully automatic method by a significant margin. This performance is achieved by doing feature selection on local depth features, since feature selection can alleviate the inference caused by the noise. That's all. Thank you.